Hello everyone, welcome to Science and Technology Standard 10 Part 1. In this video, we are going to learn lesson number 2, periodic classification of elements. Periodic classification of elements. Let us see the content of this lesson. Elements and their classification. Dobereiner's Triads. Newland's law of octaves. Mendeleev's periodic table and modern periodic table. Can you recall? Let us have the question and answer sessions now. What are the types of matter? As we know, there are 4 natural states of matter: solid, liquid, gases, and plasma. Second question, what are the types of elements? Basically, elements are the pure atoms. These 3 groups of the elements are metals, non-metals, and metalloids. What are the smallest particles of matter called? A molecule is the smallest particle of matter. What is the difference between the molecules of elements and compounds? The only difference between a molecule of a compound and a molecule of an element is that in a molecule of an element, all the atoms are the same. For example, oxygen. If I am talking about a molecule of oxygen, all the atoms in this molecule, that is O2, are the same. Another example is Cl2. When I say about chlorine molecule, both atoms are purely of chlorine. Whereas in a molecule of a compound, all atoms are different. We know that water is a compound. When I say that one molecule of water, it contains 2 atoms of hydrogen and 1 atom of oxygen. So, in a molecule of compound, all atoms are different. Let us come to the starting of the lesson. As classification of element is very important to understand the number of elements which are present in the nature. Today, 118 elements are known to the scientific world. Around year 1800, only 30 elements were known. More number of elements are discovered in the course of this time. More and more information about the properties of these elements was gathered. Now, as the number of elements are more, to study them, the groupism becomes important, and hence the classification of elements is necessary to study these. As I acknowledge about elements and their properties went on increasing, different scientists started trying out different methods of classification. In the year 1817, a German scientist, Dobereiner, suggested that properties of elements are related to their atomic masses. For this, he made groups of 3 elements each, having similar chemical properties, and called them triad. Dobereiner stated in his law of triads that the arithmetic mean of atomic masses of the first and third element in the triad would be approximately equal to the atomic mass of the second element in that triad. Let us learn these triads with some examples. Here, the first example. Calcium, barium and strontium form one of the Dobereiner's triads. Atomic mass of calcium is 40.1, atomic mass of barium is 137.3. If we will find out or calculate average of these two atomic masses, that is 40.1 plus 137.3 divided by 2, we get the answer as 87.6, which is atomic mass of strontium. Second example, halogens, chlorine, bromine and iodine constituted one of the triads according to Dobereiner's. Again, let us see how. Chlorine 35.4 atomic mass and iodine 126.9 atomic mass. If we will calculate average, that is 35.4 plus 126.9 divided by 2, I'll get the answer as 79.9, which is atomic mass of bromine. So Dobereiner said that, or he stated that, the properties of elements are related to their atomic masses. Next came as Newland. The scientist Newland correlated the atomic masses of elements to their properties in a different way. In year 1866, Newland arranged the elements known at that time in an increasing order of their atomic masses. He didn't try for the average, or he didn't go for the triads. Whatever elements were found that time, he arranged all those elements according to their atomic masses, and he wrote them as musical note. In the Indian music system, there are 7 main notes, namely Sa, Re, Ga, Ma, Pa, Dha, Ni, and their collection is called Saptak. The frequency of the notes goes on increasing from Sa to Ni. Then comes the Sa of the upper Saptak at the double the frequency of the original Sa. It means that notes repeat after completion of one Saptak. The 7 notes in the Western music are Do, Re, Mi, Fa, So, La, Ti. Here, Newland tried something like this. If you'll see this figure, Li and Na. So if I'm starting from H, I can call it as Do. Li becomes Re. Be becomes Mi. B becomes Fa. C is Sol. N is La. And O is Ti. Then I will come back to Do as H for F, that is fluorine. So hydrogen and fluorine comes under Do according to the musical note, that is Sa. Lithium and sodium comes under Re. Beryllium and magnesium comes under G. Boron and aluminium comes under Ma. Carbon, silicon together under P. Nitrogen and phosphorus under the, and oxygen and sulfur under Ni. So in this way, Newland tried his octave. Newland's law of octave states that when the elements are arranged in the increasing order of atomic mass, the periodicity in properties of two elements which have an interval of 7 elements in between them would be similar. This is called as Newland's law of octaves. But he had some limitations. Limitation of Newland's octaves are: it was only up till calcium that the classification of element is done via Newland's octave. Many limitations were found in Newland's octave. Newland fitted all the known elements in a table of 7 by 8, that is 56 boxes, and Newland placed these elements into all these boxes. The discovery of noble gases added to the limitations of this method, since they couldn't be included in this arrangement without disturbing it completely. Newland's octaves did not have provision to accommodate the newly discovered elements. Also, Newland placed 2 elements each in some boxes to accommodate all the known elements in the table. For example, cobalt and nickel.